Good afternoon, everybody. I'm Nicolo Barbieri, and I'm a researcher here at the University of Ferrara, the Department of Economics. And today I'm presenting a joint work with François Peruchat and Davide Consoli, who are based at Ingenio in Valencia, in Spain. And our paper substantially investigates which type of regional knowledge structure favors the generation of innovation. And in particular, we focus on a particular instantiation of innovation which concerns green technology, so those that try to decrease the environmentally harmful behavior. So before describing the technicalities of the paper, I would like to spend just a few words on this broader research project in which the paper places itself. And in particular, we have seen that over the last decades, economic geographers provided convincing evidence that at the heart of long-term regional development stands industry life cycle. So the ability of regions to attract new industries or to face the decline of existing one in this Schumpeterian creative destruction process. Then other scholars investigated which type of innovation is connected to the industry life cycle, in particular to different industries along their evolution. And usually we have seen that the birth of new industries stems from the introduction of more radical innovations, whereas once maturity is reached by the industry, we have, these industries are connected or associated to incremental type of innovations. Our conjecture in this, and our idea in this research project is that there is another dynamic process which goes in parallel with the industry life cycle, which concerns the technology, and in particular the technology life cycle. So indeed, different scholars investigated the characteristics of the technology life cycle. In particular, they focus on the different stages that characterize the life cycle, or when a new life cycle takes off, and so on and so forth. But the cogent question of where this innovation is generated along this life cycle is something that the existing literature substantially ignored. And we try to fill this gap, focusing on the spatial contingencies that characterize the generation of innovation, and in particular, we exploit the life cycle heuristics to observe which type of regional knowledge structure favor the development of green technologies along this life cycle. The paper draws on two literature streams. The first one is the one in economic geography. So we have the conventional, the usual question if regional development is connected to specialization or diversification. Then Franken and others made a step forwards in this, and the literature experienced an evolutionary turn. And they observed substantially that the difference is not dichotomous, but there are different degrees of diversifications, and in particular, the most beneficial for regional development is the related variety of different. Why the related variety? Because relatedness enables knowledge to flow, so incentivize the production of innovation, and in particular enhances mutual learning, and so cognitive proximity is connected to mutual learning, but still taking into account a cognitive distance to avoid the lock-in. So this is another paper that provided by Castaldi and others in 2015. They observed that all this process that leads from that brings the variety and diversification to exert its positive impact on regional development stems substantially relies substantially on the type of innovation and the structure of the regional knowledge base, okay? So indeed, we have unrelated varieties, so diversification across unrelated technological domains that favors the generation of more breakthrough innovations, whereas related variety is associated to incremental type of innovations. Of course, the basic theory, the theory behind this paper that we follow in our is the recombination theory of innovation, and in particular that innovation substantially stems from the recombination of different pieces of knowledge in new manners. The other building block of our literature review is the one in industrial economics, and in particular, as I said at the beginning, those that focus on the innovation of the type of innovation that is that are connected to different stages of development of the industries, but also, and in particular, the one that investigate the relationship between agglomeration economies and the industry life cycle. And in particular, here we have Duranton and Puga, who stress that young firms need experimentation, so trial and error, and therefore they benefit from a more diversified environment, whereas mature industries need to switch to mass production, and therefore they are favored by specialization in order to reduce the production costs. So this has been finally tested by Nefke and others. Empirically tested, and they observed that Marshallian externalities, so specialization favors mature industries, whereas diversification, so Jacob's types of externalities, are more connected to young industries. So our paper tries to, well, since this literature considers innovation as a latent variable, so we enable innovation to evolve through a dynamic process, and we try to explain why agglomeration economies differently affect the industries, in particular along their life cycle. Our main point is that there is this technology life cycle behind that co-evolves with the industry life cycle. At this moment, in this paper, we try to explore the role of agglomeration economies and the technology life cycle and how these two dimensions interact. So to do that, we try to extend the regional knowledge production framework, and in order to incorporate the regional variety and knowledge variety, and the technology life cycle. So the focus is on green technologies. Green technologies, of course, are important for achieving, and they are relevant for long-term policy objectives, but also they let's say, deserve a particular attention because different contributions stress the fact that they are different, substantially different from non-green innovation. In our recent paper, we observed that they are more complex, they are more novel, they exert higher impacts on subsequent technologies, and therefore they have some peculiar traits. So the database, we collected green patents from PatStat. We identified these climate change adaptation and mitigation technologies using the ANFTEC classification lists, which provides some codes, all the codes connected to this, associated with these technologies. Then our time span is from 1980 to 2009, and we geolocalized and we did a massive work to geolocalize all the inventors of these patents, and we projected them on 49 US federal states, which are the unit of our analysis. Then we corroborated the dataset with different sources from different bureaus and institutions from the United States. Two measurement issues at this point. We had to face the first is how to track and to capture the regional knowledge structure, and we were lucky because Castaldi and others provided these indicators, which is based on entropy, and in particular they discern between different types of diversification of the regional knowledge base. We moved from unrelated varieties, so diversification across very different technological domains. Then we have a semi-related and related variety, and here the variety is across very close, cognitive close technological fields. So we measured this using patents, and just to be clear, here you can see that when we focus on diversification across unrelated technological domains, we have diversification across very different technological fields. So we have chemistry, textiles, mechanical and engineering, and so on. Whereas as far as we move to related variety, we can observe that diversification is across similar fields that share heuristics, share scientific principles, share knowledge bases, and so on and so forth. So we have a higher relatedness as far as we move as far as we increase the number of digits in our indicator. The second issue is how to measure technology life cycle. So here we do not have off-the-shelf indicators, unfortunately, and therefore we tried different indicators, but we have observed that the best one is a combination of two main dimensions. The first one is the patenting intensity, and the other one is the diffusion of these patents. The important thing is that here we moved from US or geographical level, as in which is the focus of our analysis, but here we moved to the technological level, to the technology level. So here we collected all the patents applied in all worldwide countries, and then we exploit this information on the technology life cycle to observe the trends in green patents across US federal states. So here we substantially collected all the patents around the world, and then we measured these two dimensions. Here, when we have low value of diffusion and low values of patenting intensity, we assume that we are in an emerging phase, whereas when we increase both dimensions, we reach maturity. And of course, the maturity is when a dominant design is obtained. We have higher standardization in the know-how, in the practices, and so on and so forth. Ubiquity, I don't have time to spend, but to describe the indicator. But ubiquity substantially is the revealed technological advantage in a Balland and Rigby way of thinking about it. So these are the results, for example, of the technology life cycle. As I said, we have different types of technologies. We can see here carbon capture and storage, which is always in the emerging phase. Then we move to diffusion or development phase. I can't remember the three what is related to, but yes, we have different stages of development of these technologies. The empirical model that we tested, this here you can see that we have the two conventional knowledge inputs, R&D and human capital, which are two proxies. Then we have time trends. We have federal, state, regional specific time trends. We have state dummies and also time dummies. We have green patent families per capita in each US federal state, but also we have the green patents per capita in different stages of development of these green technologies. And we have our key variables, which are the variety variables, so related, unrelated, and semi-related variety. The results. The results shows that when we consider the green patents, all green patents, and we compare them with non-green patents, we can observe that the generation of green patents is associated to a more unrelated type of diversification, and also to a related type. But compared with non-green patents, we can see that non-green patents benefit from a semi-related variety or a related variety type of diversification. And in this case, well, this tells us that this is a first insights that tell us that something happens for green technologies, and therefore we try to observe if is their early stage of development, so the technology life cycle, that matters in these differences between green patents and non-green patents. And here, substantially, we replicated the previous estimations, and the red one are the red columns are the red bars are those coefficients that are significant, and here we can observe that once we unpack the technology life cycle, we can see that in the emerging phase, the generation of green patents is mainly connected to diversification across unrelated technological domains. Whereas as far as we move to maturity, unrelated variety loses its importance in favor of a related variety. And this is in line with the recombination theory of innovation, because at the beginning, once a new life cycle emerges, you need different types of knowledge bases. And connecting them, it leads to an emergence of a new technology, and probably to a new technology life cycle. Whereas as far as we move to maturity, a dominant design is reached, is established. So we have common practices, we have common know-how that characterizes the development of these technologies. And here we can observe that variety across similar technological domains favors the generation of these more mature technologies. This is just to conclude, and this is the way ahead. As I said at the beginning, we try to answer to the question of why agglomeration economies and different agglomeration economies are associated to different industries along their life cycle. First, in this paper, we made a first step, observing the agglomeration economies on the technology life cycle. But as I said, we would like to connect the industry life cycle and the technology life cycle, and of course try to investigate the connection between this diversification and the long-term regional development. Before concluding, I would like to alert your attention on this new platform that we are creating, which is the Green Tech database. We created this website in order to share our data to policymakers, but also to academic and non-academic researchers. Here you can delve into different statistics. You can obtain country profiles, but also the focus on different technologies. And this is a collection or substantial of all our statistics. So. Thank you very much for your attention, and any comment are welcome. Thank you.
Thank you, very interesting. Especially the database. We will surf on it for sure. Any questions from the audience? that. Caroline?
Okay, maybe it's just because I'm fainting from the heat. So were you? So I got the part where you're focused on the industries and this and comparing the kind of spillovers from industries, but you weren't getting to the spatial part yet, were you? Or was spatial?
Well, we focused on on the technologies, and we try to observe, yes, how knowledge spillovers characterize each region, these U.S. federal states, and how this type of knowledge spillover favor different type of, or are associated to with different types of innovation along the life cycle. Yeah. Yeah, of course.
Sorry if it's a broad, maybe naive question, but I wonder, because I don't have a precise idea, whether there are, you talk about region, you mean states, right?
Yes, exactly.
Okay, so but is there any heterogeneity in terms of policies that may have an impact on the way in which you determine which kind of innovation affects the life cycle in each phase of the technology?
Yeah. Okay. This is, of course, a very good point, especially in this this workshop. We did not included a specific variable to control for environmental policies, but. We included, we tried to control for it in a very rough way, of course, using federal states' time trends, and also considering the fact that in the U.S., well, first of all, we consider the U.S. federal states for this reason, in order to capture the environmental policies, which are usually introduced adopted at least at the U.S. federal state. But we also have pardon. Yeah, indeed. Pardon. Yeah, the state level. Yeah, sorry, at the state level. Yeah, federal state level. Yeah, the U.S. federal state. So California. That's okay. No, just to be and also for those policies. Broader policies, for example, the Clean Air Act during the 90s, or the Recovery Act, which by Obama, which included some sort of different policy instruments also for the green side. We try to we control for that in a quite rough way using the time dummies. Okay, yeah, but yeah, we try to we are trying to collect data on this policy at the U.S. federal state. Yeah, absolutely, yeah.